Hi, my name is Hunter, and I'm going to try to show you how to make a geometry from the beginning to end in OnShape. And there's many ways to make geometry, but this one is going to be focused on geometries that will be imported into CFD software. So first, you make an OnShape account, and then your main OnShape screen will look like this. You can see there's a whole bunch of projects here because I've been working on some stuff, but yours will be empty. Go ahead and click Create and start a new document. I'm just going to call this one Tutorial. So this is what your screen looks like when you first start out. It's going to be empty, and the scroll wheel will zoom in and out, so you can kind of look at the fine details of stuff. You can box select things with left click. So if there's multiple objects in the screen here, we'll be able to click multiple of them. You can right click and rotate around, so we can look around at all the details on every surface of something. And then if you click the middle mouse button and drag, it'll pan you. So if something's long, it's pretty helpful to be able to do that as well. So what we're going to be trying to do is making a mixing elbow. I think this is a really good tutorial on how to do a lot of things in OpenFOAM. Of course, this won't be everything, but when it comes to CFD, this is very useful, and I think once you've done this, you'll be probably able to learn a lot of things on your own. So one thing that's very useful when you're looking around in OpenFOAM, sorry, not OpenFOAM, in OnShape, is being able to click these boxes here. I didn't realize that this is an option until later, but this is very useful, and you can kind of make micro adjustments. So if something being very well aligned is important, then these camera controls is very good. And also you can even look at like isometric views by clicking on these. So like 3/4 views, really like analyze something. So to make this mixing elbow, we're going to be going off based off this diagram. So it gives us some numbers here as a point of reference. And it doesn't give us units, but we're going to assume these units to be meters just for simplicity. And the way you'd be able to change that here in OnShape is if you click these three bars, you go to workspace units, it'll actually allow you to change the default length unit. So in OnShape, it'll give you a number 1, 2, or 3, but doesn't specify units. And here you'll give it those units. Okay. Oh, you'll notice another thing on there. I can change mass units. This will be helpful for if you define the density of certain solids. You can actually analyze the mass of a particular part. So what we're going to do is we're going to make this mixing elbow. So here's a side view of the elbow. You can see there's like a bigger portion of the pipe, and connecting to it there's a smaller portion. Here's a dead-on view. You can kind of see inside the pipe. I can see kind of the outline here of this smaller mixing portion tilted on its side. It looks about the same. And here's a 3D rendering of it. Okay, so first thing we should do, we should start out by making the skeleton of this pipe. So what does that mean? So what that means is in OnShape, everything starts from a sketch. So we're going to start with a sketch here. And we are going to define the inner diameter of this pipe. So we see that it's 1 meter. So when you make a sketch, since it's 2D, we need to define a plane that it's going to be imprinted on. So let's put it on the front plane here. We could have easily chose a right plane or whatever you like, but let's start from the front plane. Let's now make a circle. So these are all your options here for drawing. And there's some more here too when it comes to editing lines. But usually you're going to want to start from here, like some squares, And if you hit these, there's different ways to define a circle and even ellipses. But we're going to do a center point circle. This is useful for when you know the inner diameter of something, which we do. And you'll notice I left click and I can actually expand and contract the size of the circle here. And I'm going to click to set that circle in. And you'll notice that the inner diameter here is 0.279, which is wrong. So what we're going to do is edit the dimension of it. So you can click this. I like to just press D, click on the circle itself, and it'll allow me to adjust. If I left click again, and it was 1 meter. So I just press 1 and enter in inner diameter. And now we have that face of the circle. Okay. So now we got to confirm this sketch, and we have this circle now. So we're going to be making the skeleton of this shape here. So another good thing to do is define the depth of that pipe. So let's look at the drawing again. There's 3 meters, and then another 3 meters this way. And then we can see that the curve here is actually a circle with a radius of 2. So we're going to start by doing the length of the pipe. So you got to pick a sketch plane. We're going to do the right plane this time because we're going to give that circle some depth. And we're going to pick a line. This right here is showing that it's the intersection. Click on that. And I'm just going to click again because I like to define the length later. And then when you do the line, it'll want to keep making the line longer. You can stop by just pressing escape. So press D to edit the dimension. I like this because I can define it with a whole bunch of decimal points, make sure it's really accurate. Make it 3 meters long. And now we have a circle, and attached to it is some depth. Let's confirm that sketch. And what we can do is actually we can sweep this. So we can take this sketch, and we can say, oh no, sorry, this would be a solid. So let me show you what I was about to incorrectly do, is create a solid. And this just makes a cylinder. Okay, but we want it to be hollow inside. So let's select surface instead, and saying, hey, click the edge of something that you want to sweep. So we click that, and now we got a hollow cylinder. So that's that first section of pipe. Awesome. And that's what it would look like. But of course, we want to add some curvature to it. So let's exit out of this. And let's define that circle that represents the curvature. So another sketch. You can start from the right plane. And if I remember correctly, yeah, I had a radius of 2. So let's do that. This line here will represent the radius. So click, press D, 2, enter. This is the radius of our circle. And then we could start from here and make it a center point circle. And that would be one way to do it. But I think what would be even cleaner is if we use an arc, a center point arc. So we define where the center of the arc is and then sweep it along a path. But for that, we'd need 3 points. So let's make another line. Press escape to get out of that. Press D, 2 meters. We have another one. Let's check. Another sketch, right plane. And this time we're going to go center point arc. So define the center of the arc. It's gonna tell you that like it wants a radius now. So hey, let's give it this radius here. Sweep it along that path, and then click here. You'll notice it kind of snaps to the intersections because it knows that we want to keep things symmetrical. And then we're going to hit check. So here's this curve. And of course, we can add this to the sweep path. Let's do that. And then you'll see that the circle, oh no, sorry, that's revolve. Sweep, surface, let's give it that path. And it can actually add the curvature. But we're going to want to add one more section of pipe Actually, let's confirm this. I want to show you how to edit things later, which is very nice about OnShape. Let's add another sketch, right plane, line, and 3 meters. Let's make it exact. Click confirm it, and let's go back to that sweep. So we right click, edit, and this time we want this sweep to be a little bit longer. So let's go to sweep path, and I want to add this next sketch, but something's going on here. Let's see. Oh, I see. So the issue is the sweep was started before the sketch, so it doesn't recognize that the sketch exists. So one thing that's very useful is, hey, let's put this further down the timeline so that the sweep can recognize that the sketch exists. And then let's add that length. So now we have what's looking pretty close to our elbow. But we want to add this smaller section of pipe that connects to it. So let's do that. Let's confirm this. Okay, it looks good. And how can we do this next part? Let's see. We're going to want to do the right plane, of course, in the same plane along with the rest of our skeleton. And we know that the section of pipe here is 1 meter long. Okay. And it's starting what looks like to be exactly the end at 45 degrees from this curve here. So we can probably, best way to do this would be to make another circle, or we could do another arc. Because if we tried to do this by just doing this, it's not exact. We want this to be exact, and that's very important for OpenFOAM. So maybe we defined another sketch, and then from there make it connect. Or maybe what would be better is using an arc. So let's try that instead. Let's make another arc. Make it so it won't give me a connection here because there's nothing to connect to. So actually what I'm going to do is stop that. It seems like go. What we can do is just edit it later. So this won't be exactly 2.5 radius, but we'll make it 2.5 later. And let's see, can we edit this arc? I actually don't know. Let's figure it out. Check mark it. Edit. Can we press D on this arc here? Oh, we can. So we can change this. Let's make it exactly 2.5. Now for the maybe a better way to go about this then would be to delete that sketch, start again, and then let's make a midpoint. Okay, sorry, I had to pause for a moment because I had to figure this out. I noticed that when I hover over this new sketch, so this is a sketch that was the arc along here, it actually shows a midpoint, so we can use that as our point of reference. Sketch, right plane. We're going to look for that intersection, which happens right here. You can see because of the way that the icon here changes. So this is saying, hey, it's going to pierce the line here. But then when you go up to here, it's saying that's the midpoint. I'm going to click there. So of course the midpoint of this angle would be 45 degrees. And there is a way to actually add your own midpoint. It would be this right here. But we're going to use the one that OnShape has given us. Click that midpoint. And it was 1 meter. There you go. So let's make it exactly 1. Sweet. And we have another line. And of course, if we swept this, it would actually intersect the surface, and there wouldn't be a hole here either. So it wouldn't be very useful. So what we can do is let's pierce this surface with another object. But first we need to give it a volume, right? So let's give it an area so we can give it a volume, pierce that, and then connect the two. So I'm going to click here and show you exactly what I mean. I'm going to go to the bottom, choose this top plane to be our sketch plane. And as you can see, I kind of lost the dot here. I guess you could see it if you hover, but I lost it, so I'm just going to right click and edit. But since we chose it to be our top plane, it's going to be, the sketch is going to be parallel with the top plane still. We're going to, it's not allowing me to select. Maybe we need to be in this view. It's not letting me select. Let's try editing this already existing sketch and adding a circle to it. That might work. There you go. Oh, but it's in the right plane. Okay, that's an issue. Okay, so to get around this, we're going to have to make our own plane. So you can select this here. Oh, by the way, if you ever need to look for a tool, try this. And I think sometimes they give you videos too if you need help. Where would it be? Let's see. Search tool, share. I think that there's a help button somewhere. Usually what I do is just Google, let's see. So we want to look at plane. Let's go plane, OnShape, plane. And it's actually going to give you videos, or it looks like this one doesn't give you a video, but this one's going to give you step-by-step instruction of how exactly plane works. But I can just show you right now. So let's get a plane. So what this is going to do is just like the top, front, right planes I was using before, it's going to make a new plane for you. And I want the plane to be in the vertex of sketch 7. Let's see if this works. No, we need to give it an area. Let's see. So I think it will be parallel to the top plane. So let's try that again. Click. Use the other plane as the entity of the top plane. But then let's offset it. But you can see the arrow, and we're just going to offset. Change it to the other direction. Offset it up to this point. So this is how far? It's 0.5, right, to hit the radius, and then another something. Let's see. How can we measure this? We can measure it by clicking this measuring tape. Click from here to here, and it'll tell us the minimum distance to get to those two. Oh, no, that's the wrong point, because it's finding the minimum distance between these 2 points. So you could do some geometry and figure out the distance here, but let's save some time. Let's just make another line. Start it from here, and of course it's parallel with the right plane. Let's make it intersect here. And then we're going to use this point as a point of reference to measure from. So we're going to measure here. Okay. So it's 0.268 meters away. So that's going to be our offset distance. So we're going to create another plane and choose the top plane as the entity from which this plane is going to be created, because it's going to be parallel with the direction that we want the circle to be over here. And we're going to give it an offset. So we're saying from this plane, go in this other direction by, it was 0.238. Sorry, I've forgotten. 0.268. So plane. Pick this plane right here. Offset it. Other direction. 0.268. Oh, but it's 0.268 plus whatever this length is. So I should have measured from here to here. No, actually it'd be 0.268 plus 0.5, so 0.768, because it's up to the radius here first, then another 2.68, 0.268, so 0.768. There you go. And this will give us another plane that we can use as a reference to make another sketch from. So let's make another sketch. Use this new plane that we defined as where we're going to be parallel from. And let me just give you the reference here. You see how they coincide there? Going to choose that dot as our point of reference here. So let's sketch plane is plane 1, yes. It's not letting me select this here as our point. Okay, sorry, I had to pause again. I don't know everything. I forget things sometimes, and I figured out something on how to get this circle to connect to this point here. So what we can do is pick that plane, select a center point circle, and then you can choose Make Connector. And that actually allows you to connect to this vertex here. And then you can actually use this as a plane to draw from. So I think you can actually do that without this plane too, because you notice that it becomes a sketch plane. So this step was not necessary. I have used this way before, and sometimes it's helpful, but in this particular case, this Make Connector is a lot better. So let's use that, make a circle, make a small circle here, and then of course we got to change its diameter, inner diameter here to 0.5, I believe it was. Let's double check. Yes, 0.5 diameter here. And then again, we're going to sweep this just like we did last time. But what we want to do is make sure that there's no surface here that's blocking it. So let's see. I can think of a way to do that. One way would be to, let's sweep surface, picking the edge of that surface, and then the path would be this vertex here. Oh, but it doesn't make it all the way. Okay, so there's another way to go about this. Extruding. Let's try that. We can say extrude, and then up to face is usually pretty good. And then that face would be, we're saying, hey, when you touch this object, stop sweeping. And then that stops it there. But there's a problem because we have a surface here, and of course we need water to flow through there. So there's two ways we can go about that. Because it created a new face here, it looks like. And we can actually delete that face. I think I'm going to show you both ways that I could think of a solution to fix this. One is something called splitting. So we can split, say, okay, the part that we want to split is this face here. Split it with this entity, and then this entity is considered the tool that you're splitting it with. Imagine like we're cutting into this face with this small section of elbow, and we're going to want to keep that because this tool is actually relevant. And we're going to do that, accept. And of course, that's going to make a new surface, its own entity, and it's going to show up here in this list of surfaces. So we can see surface 1 is this one, surface 2 is this new one that got created, and surface 3 should be this section of pipe. And then we can actually delete that face. So it's right here. Or you could just type in delete face. One way to do it. And now we have a hollow pipe. This would work. This is exactly like that other diagram here. But I want to show you a different way. Another way to go about it would be, so let's You can always press Control Z to go back, by the way. Or you can just like delete these steps here. So let's reverse that split too. Let's say that we wanted to do it a different way, and you'll find your own reasons for wanting to do it this way. Maybe it would really depend on your object, your geometry. But let's extrude it. So what extruding does is makes a sketch into a volume, right? And actually, we can't do it. Oh, we could actually. If we chose the sketch here, chose a face here. So you'll notice that sketch went away just because when you extrude or sweep something, it will actually make the sketch disappear. But you can always just tell it to come back by clicking this eye. We say make a new solid, and let's just give it some depth. Like let's say 0.75. Let's see, will that go through the other side? Oh, actually it doesn't quite reach. Let's give it like one. Oh, sorry. Let's give it like 1.5. There you go. So you can see it goes all the way up to the other side. You can kind of see it poking out through this side here. Poking out through. And then that made a solid. So now there's like a solid cylinder in there. And click that face. And we're actually gonna do some called Boolean. So you subtract, and the tool this time is that cylinder that we just made, and tell the target to be this face, and then you click it. And it's basically gonna kind of use it as like a drill, if you think about it that way, to go right through. And it's hollow again. So there's two ways you can go about doing that. But this is how you make a mixing elbow. And there's so many other options, tools here that I didn't go over. Some will be helpful for CFDs, some won't. You can even export this as a way that you can 3D print if you want it. Although this would be a really big pipe, because what is this, 3 meters? 3 meters. I don't know if we have a 3D printer big enough for that. So what you'll do next, if you're working with OnShape, is you will export this shape. So the way you do that is right click, export, and you're going to want to be bringing this into Salome first. So typically you'll keep your format as step. You can name it whatever you want. And then I think that was surface 1 that I was trying to export. It'll only export this surface if that was the case. But if you want to export the whole thing, just hold shift and select everything, or maybe you can just individually select things, right click, export, and it'll have everything all connected as one piece. But I noticed I forgot something. So before you bring it into Salome, one really odd thing is that you do need to make sure that this geometry is waterproof. So as of right now, if I were to dunk this section of pipe into, just submerge it into water, you'd see that water would flow through, right? It would go inside. When it comes to CFD in OpenFOAM, this cannot be the case. It has to be waterproof, and you'll understand why later, but I'll show you how to make it waterproof straight here from OnShape, so you can bring it directly into Salome and then move on to something called waterproofing, repairing, and meshing. So to do that, what you can do is first, let me hide these sketches because they're distracting. There you go. And you can, I think you can also click hide all sketches. No, that's a Salome feature. Sorry. So let's fill in these holes so that it's waterproof. So what we'll do is we'll select this circle, and I don't know where this, I forgot what it's called. So we're gonna do this, and it's called fill. We're gonna add. You'll notice there's two options there. Sorry, I kind of breezed through that. Edit. I chose add, so it's saying, hey, to this surface that I selected, add a piece to that. That's actually the incorrect option here. These should be different. Because if we are simulating this in CFD, let's say that this small section of pipe is one of the inlets, then what we'd do is we'd call this face right here inlet, and this is actually where the water would be coming from. And then it would be flowing through this tube. So we want to actually make it a whole new surface. and it'll show up on this list of surfaces. So yeah, we'll call it that. And we're going to want to do the same for all of them. Fill, new, check mark it. Awesome. Keep doing that. Fill. Oh, there it is. And oh, I accidentally clicked add. Let's go back. Edit. New. There you go. And so now we have a completely waterproof geometry. If I were to dunk this in water inside, no water would go through. Now let's rename it just so that it's pretty organized once we export it. Rename. So this surface one, sorry, which one was that? So that's this big section of pipe. Let's, in fact, let's connect these together, because if we think about it, this is one pipe right here. Let's Boolean them. So Boolean. And before we use it to subtract, but this time we're going to use it to union, and we essentially glued the pieces together. Now they're one surface, and let's call this one pipe wall. And then we have this other surface. We're going to kind of, let's say that this is an inlet, this is an inlet, and then all the liquid leaves from this face. So let's call this like inlet small, because it's smaller than the other one. And then let's rename this one to inlet big. And let's rename this one to outlet. There you go. So when you export it, you're going to want to keep them separate. Oh, is something odd here? No, that's good. Okay. And export it. Let me, I guess, show you the process. I'll show you what my organization looks like here. Export. And let's not add this prefix here. Option is download. Let's do that for all of them. Export. And you're going to want to keep these separate. So you'll notice that I'm not selecting them all. Because these faces will have completely different properties. Okay, and export. I accidentally left the prefix here, so we're just going to leave that for the other ones. But this is just your naming, just for your organization. And we've downloaded all of them. And you can put them into, let's see, so what I do here is I got geometries. Let's call this one tutorial. And let's put all those files in there. And I can't see the last one. Pipe wall. There you go. There's that. Got all the geometries downloaded as a step file, and they're ready to go into Salome. And thanks for watching. And keep on foaming.